In this video, we are going to talk about the 5 number summary. So, to do that, what we need to do is to talk about quartiles first. So, what a quartile or the first quartile of a data set is, and it's denoted by Q sub 1, it is the number that divides the bottom 25% of the data from the top 75%. So here down at the bottom, you can see that there are pictures of some different distributions of the density curves. So here you have a data set, and here's another one. So if you look, Q1 is labeled on here, and so that would be the point on sort of the horizontal axis of the graph here, and about 25% of the data would be below Q1, and then 75% would be above. And it's the same thing on each of these data sets, right? Here's Q1, so about 25% of the data is below, about 75% is above. Okay. The second quartile of a data set is the median. All right. And so if you remember back in the lesson where we talked about the median, we said that the median is the number that divides the lower 50% of the data from the top 50% of the data. So here is Q2, and that's just the median. So that's really nothing new. And then the third quartile of a data set, and that's denoted Q sub 3, that is the number that divides the bottom 75% of the data from the top 25%. So here in these distributions, you can see it has Q3 labeled on each of the distributions, and there's about 75% of the data below Q3 and about 25% above on each of these distributions. Okay, so that's what the quartiles are. Okay, so what we want to be able to do is to find the quartiles of a data set. And so to find the quartiles of the data set, the first 2 steps are just finding the median. So remember, to find the median, you're going to arrange the data set in increasing order and then find the median, just like we did in the previous lesson. Okay. All right, once you find the median, then what you want to do is divide the ordered data set into 2 halves, a bottom half and a top half. Okay. And if the number of observations is odd, then what you want to do is include the median in both halves. Okay. That's how our textbook is doing it, so that's the way we will do it. And then once you do that, once you divide the data set into halves, and if it's odd, right, including the median with both halves, then what you want to do is find the median again of the bottom half, and that median of the bottom half is going to be Q1, the first quartile, and the median of the top half is going to be Q3, okay, of the original data set. All right, so basically we're just finding medians here, and there's this one little twist about the number of observations. All right, let's take a look at this example. All right. So in this example, it says, in the article, grandchildren raised by grandparents, a troubling trend, California agriculture, and Blackburn considered the rates of children under 18 years of age living in California with grandparents as their primary caretakers. A sample of 14 California counties yielded the following percentages of children under 18 living with their grandparents. Okay. So, the first thing is that we need to do, here's the data down here, we need to arrange this data, right, in ascending order, and I've already done that because that'll take a few minutes to do. Right, so here it is. Let's see. Yeah, that's looking good. Okay, so here I've arranged the data in ascending order, and then the first thing I want to do is find the median. Okay, so the median, there are 14 data points here, right? 7 by 2, yeah, so 14. So what we'll have to do is to find the middle 2, right? Since it's an even number of observations. 1, 2, 3, 4, 5, 6, 7, and 8. So these two right in there. So let me just draw a line in there and mark that. Okay, and then what we're going to have to do is to average those two, right? Since we have an even number of observations, it's going to be the median, right? Q2 is going to be the average of these two. All right, so that looks like it's 10, right? 4.9 plus 5.1 is 10, and I am going to divide that by 2, and 10 divided by 2 is 5.0. So we have Q2 is 5.0. All right. Next up then is we're going to look at the median of this lower half, and that will be Q1. Okay. So on this lower half, I have 1, 2, 3, 4, 5, 6, 7 observations, right? So the median would be that number that is right in the middle, right? Because we have an odd number in the lower half. So the median, right, of that lower part of the data set would be 4.4. Okay. All right, and then Q3, we would do the same thing. For this upper half, okay. So again, we have 7 observations, an odd number, right? So there's a number that's exactly in the middle. That number that's exactly in the middle would be this 5.8 right here. 1, 2, 3, 4, right? So Q3, the third quartile, is 5.8. All right. So find the quartiles and interpret the results. All right. So the results would be that all right, the first quartile was 4.4. So about 25% of the data would be below 4.4, right? And about 75% of the data would be above it. The Q2, the second quartile or median, right? That would be about 50% of the data is below 5.0 and about 50% is above 5.0. And for the third quartile, about 25% of the data is below, right? And about 75% rather, right, is below, and 25% is above 5.8. All right, so that's the interpretation on the quartiles. All right, the next thing we want to talk about is the interquartile range, and you'll see that abbreviated as IQR. And all that is the difference between the first and third quartiles. So the formula for the IQR would be Q3 minus Q1. So you have to determine the quartiles first, or at least the Q3 and Q1, right? And then subtract those two. So a lot of times when the median is used as the measure of center, then the IQR is given as the measure of variation. So you'll see sometimes in studies, you'll see they'll give the mean and standard deviation, or they'll give the median and the IQR. Okay. We talked about resistant measures, right, in the previous section. And those are measures that are not subject to outliers, just like the median, right? It was a resistant measure. Well, then, that is it does say the median is a resistant measure here. So we've already talked about that. So the IQR, and it contains roughly about the middle 50% of the data. All right, so let's take a look at this example and how to calculate the IQR. Okay, so this is the same data set before, right? So I have all of these numbers that I calculated in the previous example. So then the IQR is going to be Q3 minus Q1. All right, so that is going to be 5.8 minus 4.4. So that comes out to be 1.4. All right, so the IQR is going to tell us how spread out the data is, right? So, about 50% of the data will lie in this range, right, from 4.4 to 5.8. Right, so the higher the IQR is, the more spread out the data is. All right, and so that is it on this particular video.